Hello and welcome. Fleet Maintenance is proud to present this webinar, The Shell ROTELLA Approach to Field Trials. I'm Mike Schmidt, Managing Editor of Fleet Maintenance, the only publication that is all maintenance, all management, all vehicle classes, all the time. Attendees of today's webinar will be glad to know that over the course of the next hour, you will hear how Shell ROTELLA puts the next generation of heavy-duty engine oils to the test. You will hear about the conduction of field trials for durability and for fuel efficiency. Attendees will also be privy to the presentation of an analysis of the results of Shell's field trials and how they demonstrate the product benefits of the next evolution of hardworking protection. On hand to provide this valuable information are Jason Brown, Global Technology Manager for Heavy-Duty Diesel Engine Oil Products for Shell, and Howard Hill, an engineer and certified AESTM heavy-duty engine rater with Shell Global Solutions. Gentlemen, thank you so much for your time. Now, a few housekeeping items before we get started. You can participate in today's webinar by submitting your questions to Jason and Howard. Simply type your question into the question window box on the bottom right-hand corner of your screen, then hit submit. They will be answering as many questions as possible during the Q&A session that will follow the presentation today. However, please feel free to send along your questions at any time, and they will be added to the queue. If at any time your slideshow does not seem to advance, just press F5 on your computer to refresh your browser. In addition, after today's live event, this webinar will be archived and available to viewers at vehicleservicepros.com, the official website of Fleet Maintenance. It will also be available on the Shell ROTELLA website. Now that we've covered all of those details, let's get things underway. I'll turn things over to Jason.
Hello everyone, and thanks Mike for the introduction. As stated, my name is Jason Brown, and I'm happy to speak with you guys today a bit about Shell's approach to doing field trials, both for durability and fuel economy. So today's agenda, we're going to cover a few things. A little bit about how we develop engine oils in general, a small dive into that area. We will also talk a little bit about our field testing, specifically about durability, and then follow that up with fuel economy and our approach to doing these types of trials and programs. And then, of course, as he said, we'll have some questions at the end. So if we jump right in, I guess it always starts with a slide about how great someone is. So we'll start by saying how great we are. For the last 9 years, we've been the #1 lubricant supplier globally. That specifically is tied to volume. But in terms of heavy-duty diesel engine oils, we actually have a lot of firsts over that time frame. So Shell was the first to help formulate and commercialize what is now considered common, but originally was low SAPs or low sulfated ash and phosphorus extended drain heavy-duty diesel engine oils. That was a program launched working with an OEM for factory fill development, which eventually led to a product we had in the market. The second bullet there is one of what we consider our best successes, focused on the launch of CJ4 engine oils back in 2006. So as that program came online for API CJ4, Shell was one of the first to help lead the commercialization and development of CJ4 type engine oils. In fact, I believe we launched our product in August of that year, where the specification was launched in July, or released specifically in July. Another point that we have is the fact that we have recently been the first to commercialize our program for CK4 and FA4 engine oils, which are about to hit the market soon. The first license date is December 1st, and I'm sure as you've seen in a few of our publications and several of the other things going around, we're quite happy to say that we feel we're quite prepared for FA4 and CK4 with our portfolio. So to dive right into the developing of new engine oils, we like to say we have a 6D strategy. And those 6Ds are dream, define, discover, develop, demonstrate, and deploy. And the focus of these 6 Ds is to help us guide the development process of the idea or concept of a new engine oil all the way to the deployment and eventual end user, to the customer. So we start with a goal, setting out a concept like we did today for CK4 and FA4 engine oil development. We set a strategy for how we're going to implement those types of products, both within our own supply chain, but also how we get it to our customers. And then we get really down to work, the real hard work of formulating and development in the discover and develop phase. These are the phases where we spend our time both scouting new chemistry, new components, but also working the technology and running the engine tests that allow us to qualify our products for both OEM specifications as well as API or even other specifications globally. The next step, and the one that we'll be focusing on today, is around demonstration. Because let's face it, we're in the heavy-duty arena. We talk about heavy-duty things, and if we really want to prove that our products are doing something, we need to show they're working in the real world, as close to the applications that our customers use as possible. That's where we need to do our demonstration. So today we're going to talk a bit about our fuel economy programs as well as our durability programs that we've utilized to prove the actual strength of our CK4 and FA4 engine oils. And then I close with the last step, which is focused on deployment. And that's really how do we get our products out of our plants to our customers. So I'll hand over, I'll hand over to Howard Hill to talk to you a bit about our field trial testing program, specifically around durability.
Thanks, Jason. We've got what's considered by many to be a large slate of vehicles. We're a little over 600 at the current point, but it involves just about every operation that you can imagine. We're primarily in the long haul fleets. It's where a majority of our stuff sets, but we do have short haul, construction, mining, ag, diesel pickups, gasoline, and LNG, which were not as popular as they once were with the price of oil being where it is right now. We always use a reference oil, that current commercial oil. You can read that as a reference oil. And since 2011, we've had many experimental formulations out in the field, and those are low high temp, high shear oils or PC11 prototypes. We'll typically test multiple products at a specific location alongside with each reference oil. And our reference oil generally has been ROTELLA T15W40 CJ4. We do that because we've got a lot of data on that oil. We know what engines look like when we take them apart, so we tend to trust that data. We do used oil sampling at a large amount. Everything gets an oil sample. Time was with the engines prior to the DD15 and their 50,000 mile oil drain interval, we didn't have to worry about intermediate or midpoint samples, but we're doing more and more of that as the OEMs are pushing the oil drain intervals out further and further. So there's 3 of them right now that are at 60,000 miles. You meet the right criteria for operation. When it comes to engine inspections, we'll take engines apart with some given parameters. We want to see clean oil analysis. We want to see engines that have accumulated a minimum of 600,000 miles. So, Howard, why do you want to see 600,000 miles on an engine? Well, I don't want to have to extrapolate the data. The formulators don't want to have to extrapolate the wear data on the engine. So if we can get them to 600, 700,000 miles before we take them apart, that's what we try and do. The real big determining factor in that is the trade cycle for the fleets, because most of the guys that we test with that are on road, they're team drivers and they rapidly accumulate mileages on the road. So when we go looking for a field trial site, we're very specific. Number one, they've got to be buying the right kind of engine, because if you end up with too many engines of one type, then you really don't need to be testing in that many. So we're spread out over everything that's manufactured in the United States. The size of the fleet is critical. The largest fleet that I have on test at this point is a total of 68 trucks in the fleet. That means they've got one terminal. That means the mechanics that see the trucks see them every time they roll through the yard. And we've got better control over our field trial operations working with the smaller sites. In the past, we've tried to work with some of the larger fleets, and if the information doesn't get down to the guys that are working on the lube rack, then nothing really gets accomplished and you're kind of wasting your time. Maintenance practices are critical. They've got to hit all the points for A, B, and C services. The types of engines I mentioned, you've got to have everything on test. Mileage accumulation, my favorite fleets for mileage accumulation are the ones that have team drivers. So you've got a driver in the back sleeping and you got one behind the wheel. And they hit the hours of service limit and the one sleeping jumps in the front and starts driving. I've got 3 East Coast fleets that are team driver operations. They're between 5,000 and 6,000 miles per week, 50 weeks a year. If you do the math on that, you can see we're pushing 300,000 miles in 1 year operation. So it doesn't take me long to put an oil into service, be ready to take an engine apart and see how it actually performed in the field. Scope and severity of service, we're all over the place. I've got trucks out west that are pulling 105.5. Those are the Rocky Mountain doubles, and they're pulling 105.5. Relationship and responsiveness. One of the biggest things that I have to do, and I've got the longest term fleet that I've still got on test, goes back to 2002. We've been testing with them since 2002. So if you've got a long-term fleet that's a high mileage accumulator, you do what you can to keep those folks happy, and I do work a lot trying to keep my field trial sites happy. If they do what they say they're going to do, and I'm going to do what I say that I'm going to do, that's the most important thing. That is what helps maintain that relationship with the fleet. All right, inspection details. What are we going to do? We're going to go into a shop and we're going to take an engine apart. No, I don't do that. We have mechanics that are certified to rebuild these engines with a warrantable overhaul. That's our goal when we contract with a specific shop to do the work for us. But myself and my team, we go out and do the actual inspection and photography in the field, and if the oil touches a part in the engine, it gets rated and it gets photographed. You can see the little bullets out there to the side. The pistons are rated for carbon and lacquer deposit, the rings of land, and the undercrown. Rings for sticking, it's not as big of an issue as it used to be. Ring sticking has kind of gone away, simply because the combustion chambers are much cleaner than they were 10 years ago. Ring face condition and the amount of chrome face remaining, there's 3 different parts that we bring back to the lab for further analysis. That's the piston rings, the piston liners, and all the bearings. The intake and exhaust valves get removed from the cylinder head. They're rated for deposits. They're photographed. The cam rod and main bearings for wear and polish, they're photographed. We'll see one of those a little bit later. The cylinder liners for wear and sludge. No, wear and polish on the liners. I skipped a line. But we do bring them back. And one of the parameters for pass-fail for a laboratory test engine is a profilometer measurement. So that we can weigh field trial results against laboratory engine results, we bring the liners back and measure them on the profilometer. That's every engine that we take apart in the field. The valve deck, the rocker covers, the oil pan, and the front cover are all rated and photographed for sludge. We don't see much because my formulators put together really, really good oils. You got valve bridges, tips, buttons, everything that's in the valve train gets rated and photographed. The turbochargers. I know the Europeans have a problem with turbocharger deposits and failures. We really don't see that in the United States. All right, so durability testing. DD15 testing that we did for our global media event in 2014 was done with a 22-truck fleet, one of the high-mileage team driving fleets in North Carolina. Very low idle. They're generally below 15%, coast to coast, North Carolina to either California, Oregon, or Washington. It just depends upon what they're going to backhaul. The engines were 475 horsepower DD15s. They were SCR and DPF equipped. It says that DD15's oil drain interval is targeted at 50,000 miles. My guys in North Carolina are, I won't say they're a little more loose with it, but they don't really base their oil drain interval on mileages. They base it on the number of trips that it makes. So our oil drain intervals on all these trucks are generally closer to 55 or 60,000 miles than it is to 50. The oil's not even breathing hard when we drain it, so we're not really worried about it. I see a note that says fleet average of 55,388, so there you go, 10% extended oil drain interval. They're a little lightly loaded, 68,000 gross vehicle weight headed west, but they are fully loaded. All the trucks that are running in that fleet are equipped with refrigeration units or reefers. And fuel economy is probably closer to 7 than it is to 6, but that's going to vary with the one parameter that we can't control, and that's the driver. So, and the driver's got a bigger effect on fuel economy than probably anything else. We have multiple Shell formulations on test. As you can see, we've got the triple protection, we've got the T5 1030, we've got the T6 540, T5 10W30, and an experimental 1540. When we did this one, we challenged the authors and the editors, the writers that were at this event, and we laid out 3 different sets of parts. One was from a 15W40, one was from a 1030, and the other one was from a high temp, high shear oil. Laid out the camshafts, the pistons, the liners, the sludge parts, the overhead parts, and said, one of these engines is not like the other one because it ran an experimental low, high temp, high shear oil. Identify which one it was. And 3 oils, and you couldn't tell the difference in the wear between any of the 3 of them. It was really an interesting event. Had fun with it. So bottom line, no discernible wear difference between 4.1 centipoise high temp, high shear and 3.0. And used oil analysis and the inspection results proved that out. That's what we had going in mind with that event, and it was in fact proven out. We've got some, the condemning limit for Detroit diesel on that DD15 on the parts per million per iron is 250 ppm. We're nowhere close to that in oil drain intervals that are pushing 60,000 miles. That's one of those things that tells us that when you've got 3 trend lines laying right on top of each other like that, your data is telling the truth. It's protecting the engine, even rolling with 80,000 GVW up and down the road. Here's another one that's led most of the OEMs. There's a few exceptions out there, but most of them are still running a tri-metal construction rod and main bearing, where you've got steel backing, you've got a thick copper plating, then you've got a lead layer, and then you've got a tin layer. So the tin goes away. It's a sacrificial layer. What you don't want to see is a rapid increase in those lead numbers, and those are basically, I think the highest one we've got there is 6 parts per million lead. What's that tell you? Well, it tells you that oil is protecting your engine bearings very, very well. And that's what we expect to see out of our oils. My primary formulator and I have a couple of opinions when it comes to field trials. We can do all the lab tests and the laboratory engine tests that we want, but when we put oil out in the field, we expect it to perform at this level. And that's the single reason that Shell is still involved in the field trial business. We've got some photographs here. Yes, they're mine. There's a set of bearings, there's a camshaft, and there's a pair of rocker arms. What we don't want to see is metal that's moving around, and in none of these parts is there any witness of that effect. The bearing that's cut out at the top is a new bearing, a brand new right out of the box bearing that we just stacked on top of it and said, let's see how this shows up in a picture, and it did pretty good. You look at the top bearing, you compare it to the 6 on the bottom, and you go, wow, Howard, there's not much difference between those. And that tells you, again, you didn't see any increase in the lead numbers, you didn't see the overlay going away, and so the engine oil, even with a low high temp, high shear 10W30, still protecting the engine. Camshaft looked excellent. The rocker arms and the contact points on them looked very, very good as well. We were extremely pleased with the results of that. Little dark box up at the top is a cylinder head. The cylinder head surface, that cold side, is rated for sludge. And you can see the numbers. So we've got 9.62, 9.78, 9 points. Basically, folks, that tells you if you took oil and you poured it on the head, there wouldn't be a whole lot left after the oil drained off. So we let all our parts drain off overnight or 16 hours before we rate them to get rid of the oil, let the oil drain off the engine, and the only thing that's left is the sludge or lack thereof. And we're very, very pleased with the lack of sludge production in our oils. And Dr. Brown, I think we will turn it back over to you for fuel economy.
All right, thanks, Howard. I really appreciate it. And it's hard to follow someone who's that enthusiastic about running field trials, but I'll do my best. So if I could just spend the next few minutes sort of giving everybody on the webinar an idea of the process that we go through of validating and performing fuel economy field trials. They're rather different than our durability field trials from the standpoint of they require more of a experimental design in terms of getting these trials up and running, but also trying to get the most efficient and most informative type of trial together so that you can really stand behind the numbers that you promote when you give a fuel economy percentage to the public. So the first thing I'm going to do is give you a little background for how do we run our programs. And that's really a program that has many, many steps. So those steps include doing work in the lab, where we literally can run various types of friction or rig tests to look at the performance of different types of lubricants, oftentimes low viscosity lubricants compared to high viscosity. Then we can run fired engine tests, where again, we're still on the bench, we're still in a room, but we have the ability to control the lubricant, but also the conditions around that engine. Even controlling things like the amount of coolant flow, the amount of fuel, the type of air that's used, or the amount of air that goes through the system. But having that ability allows us to really, really control all the parameters around running that fuel economy test in a closed environment. Our next step there, we can do chassis dynamometer testing, which really focuses on actually taking a vehicle, bringing it in-house, putting it on a chassis dyno, and running that vehicle with various lubricants. We actually have the facilities that allow us to control the temperature and humidity around the vehicle. We can control the airflow again around that vehicle, but it's one more step in the process of trying to understand how are your lubricants really performing in a vehicle. And the final but most critical step is to go out and run a third-party field trial. So this is where we work with a test facility that has a lab and the ability to have the type of test track that's a closed environment and allows us to pick vehicles, many of the ones that Howard alluded to earlier, and run a fuel economy trial in a controlled environment, but where we're still getting the effects of wind, temperature, rain, sun, and also we choose to run those trials under the effects, or at least under the conditions that our customers tend to use. So we try to use driving cycles that represent both urban or delivery driving, as well as long-haul or highway-type driving. The key to this is the fact that there's one big issue around doing all this testing. The most accurate type of testing is that which you can do in the lab. It always has the least amount of error because we control so many of those variables. But it's also the testing that isn't the most representative of what you can see in the field all the time. So going to the field, that's where customers really get the benefit, and customers really appreciate when you've had the opportunity to run field trials, such as durability or fuel economy. And really and truly, that's where the believable numbers come from. When you're actually putting that oil in a vehicle that a customer uses, and you're running a cycle that's very similar to the type of service that they're using in their particular work. So if you want to design an engine oil, or you want to design a fuel economy trial to test that engine oil, you really need to understand, how do I physically design the engine oil so I can get better fuel economy? And that comes from basically all the steps I alluded to in the first slide, but this slide here gives you a little bit of the output of that type of data. So you don't just sort of walk up and decide, I think I'll just make a low viscosity engine oil, and lo and behold, it'll give me a better fuel economy number. No, you actually physically design it. You understand the parameters that go into making a fuel economy engine oil, and you literally design the oil around those parameters. So what I'm showing here is a little bit of something we call a correlation. And that correlation is the exact information that tells us how do we relate fuel economy to a parameter that we use in the industry called high temperature, high shear viscosity. So what is high temperature, high shear viscosity? The short story is, it's after you take an oil and you churn it up, how does that oil perform? How thick is it after you've ripped apart the viscosity modifier and some of the long things that are in it? So it's a much closer measure of the viscosity of what the lubricant looks like in the engine, because in the engine, the oil is being churned up and run around, and many of the high molecular weight things are being broken down. So what you can see here is there's a very, very linear relationship between fuel economy and what we call high temperature, high shear. Basically, as you reduce the high temperature, high shear, your fuel economy numbers improve. So, with that bit of information about designing the engine oil, that led Shell to begin doing some work that we call our Global Fuel Economy Program. And what it's really focused on is the fact that we recognize that there are manufacturers of engines that exist all over the world, not just in the United States, not just in China, but they're global suppliers. They send those same engines all over the place. And if we really want to know how our lubricants are performing, not just in one region, we really want to know how they're performing everywhere. So what we've done is we've decided to take 3 different test sites and run a third-party fuel economy trial. And so those test sites were, one was in Germany, and that trial was completed back last year in 2015. We completed a third-party fuel economy trial here in Canada, well, in Canada, not here, but in Canada back in February. And then we have one planned to conduct another third-party fuel economy trial in China next year. In each of those trials, we chose the most popular engine manufacturers, and of those manufacturers, their most popular engine type. So as you can see, in Germany, we chose Volvo, DAF, MAN, Scania, Daimler, and Iveco, who are currently the top 6 manufacturers in Europe. And for our American trial, we chose, of course, Cummins, PACCAR, Detroit Diesel, Navistar, Mack, and then we have to think a little more broadly than the fact that there's just heavy-duty diesel. We also put a light-duty diesel pickup truck in the mix. And that's because, in truth, there's more light-duty pickup diesel engines on the road in America than there are even Class 8 engines. And, of course, we'll follow the same pattern in China. We'll pick the top 6 engine manufacturers for China as well. The real crux of this testing actually is in this bottom line. It's the fact that we use industry-standard methods and industry-standard testing to actually validate our fuel economy numbers. And this is where I believe we have a real strength. We take well-known and well-analyzed SAE protocols, such as the J1321 protocol and the J1326 protocol, who are focused on highway driving and urban delivery type driving, respectively. The key to this testing is the fact that we're trying to choose cycles that represent exactly the types of service intervals that our customers use. So when we generate a fuel economy number, we're saying we expect up to this kind of performance for that lubricant in the type of service that you're used to using. The last piece of this is all in the design of the trial. And it's the fact that every fuel economy number that we released is held to the high standard of what we call the 95% confidence interval. Now what that means is, if I run that same trial 100 times, 95 times out of 100, I will see a difference between the two oils that I give a fuel economy number for. It's hard to get much better than that. And in fact, statistically, the only step better is 99%, other than, of course, 100. So on each of these tests, we choose 6 vehicles, so 1 engine from each manufacturer, and that 1 engine is basically selected, but we try to be compatible to all the other engines, so we select similar technologies across the 6. So allow me to share a little bit of the output of one of those trials. So what you're looking at is the fuel economy data that we got from our Germany trial that we conducted back in 2015. So we took 6 oils, 2 of which we considered test oils for this. Some of the others are just candidates on different technologies. But the two that are really important here are, one, our reference 15W40, which was a CK4 technology and is one of the CK4 technologies that we are prepared for December 1st. And the other is a 5W30 CK4 technology, again, in preparation for December 1st this year. We ran both the urban and highway cycles using those different engines from the different OEMs. And of course, we have, as you can see on this graph, error bars that represent the 95% confidence intervals. So what you really need to look for here is if the error bars overlap, then that means those oils are not statistically different. But if there's space between the bottom of an error bar and the top of the next one, those oils are statistically different. And what you can see here is that our 5W30 CK4 product delivered up to 2.8% fuel economy in this trial versus our 15W40 CK4. So just to sum up what we do with respect to these fuel economy trials, every time we run one, we have them statistically validated, focused on driving under what we consider real-world conditions, where, of course, we have the environmental conditions of being outside. We try to have extensive coverage of various engine types and operating conditions, so we do long haul, short haul, urban, as well as some mixed driving conditions. And we choose a wide range of OEMs, which I won't read off the list, but basically it's a list of the major European as well as U.S. manufacturers. And, of course, although they're not listed, we do some testing in Chinese manufacturers and Indian manufacturers as well. So, in summary, what do we feel that we're so strong in? It's the fact that we feel our fuel economy numbers are statistically sound. We design trials that are focused on delivering the best possible numbers and getting the best comparison of data. We control the variables that we can't standardize. So anything that we look at in terms of matrix design, load, all of those things are controlled, standardized, and kept the same across the different trials. But there are variables that you can't necessarily standardize, so you manage them. And those include things like weather, humidity, wind. So we try our best to make sure that we're running under similar conditions so that we're getting similar types of results. And the last, of course, is the fact that we use protocols that anyone could use. The SAE protocols are widely available to anyone who would like to use them. And we simply took the parts of those trials, of those different urban cycles, we simply took those cycles and added them to our own fuel economy assessments. So in summary, you've had a chance to sort of look at what we do. We look at both durability and fuel economy trials that are focused on giving us real-world data. So information that we can share with our customers that has some credibility when compared to what they do day to day. We validate that performance in different types of service intervals, different types of engines. And obviously with the introduction of a new category, that's been a key part of proving that our oils are ready for launch on December 1st when it comes to the new API category. We feel that we're both strong in the durability section with both the FA4 and CK4 engine oils, and we also know we've got some pretty strong fuel economy numbers coming as well with respect to the FA4 side. We do real inspections, we show real parts with real data, and we have rated, certified personnel who allow us to basically go into these teardowns and assess how the performance really looks and what the customer is really going to see. And of course, we've got some fuel economy numbers that we already have on the market today. We've got our ROTELLA T5 1030 that delivers up to 1.6% fuel economy. We've got a T6 multi-vehicle product. Our 530, which as I just stated a few minutes ago, is expected to deliver up to 2.8%. And then we have a 540 in the market today that's still CJ4, but will transition to CK4, and it delivers 1.5% fuel economy today. And with that, I guess I can close our presentation and open the floor for any questions.
All right, great. Thank you so much to Jason and Howard for that great presentation. We've got a few questions that have come in, and if you haven't done so already, please go ahead and type your questions into the box, as Mike indicated at the beginning of the presentation, and we'll be happy to answer those as best as possible. So I'll go ahead and start the first question here. So are the oils you test mineral oil or synthetic?
Both. So the short answer is we test both conventional mineral grades. So where Howard was talking about earlier, our Rotella T Triple Protection, that product is currently a mineral grade 1540. The T5 product that I just spoke about is a semi-synthetic product. And then even if we go to the 5W40 as an example, that's a full synthetic product. But we test mixes of all different types of mineral and semi-synthetic as well as full synthetic grades.
Great. Thank you, Jason. So I've had another question here. When will these new oils be available?
So for the CK4 FA4 specification, December 1st is the time that you're first able to license those products. So that's the first time that you should see any oil marketer putting CK4 FA4 on their bottles. However, we have been able to transition some of our fluids a bit early. So we have some products that we've been able to transition with respect to the triple protection because we've been able to cover all of the current specifications today. So we've technically got a ready, capable CK4 product out there already, ready to go. So with Rotella T Triple Protection, that is in the bottle today.
With that new name being Rotella T4 Triple Protection 15W40, as well as the Rotella T5 10W30 synthetic blend. All right. Let's see here. Another question. What is or will be the name of the new oils? Will there be any name changes with the new oils?
So as we just said, so the current Rotella T Triple Protection will move to a new name, which is Rotella T4 Triple Protection. There won't be a name change at the T5 level. It will still be Rotella T5 10W30. We will have for our T3 offering, we have today Rotella T3, but it will become Rotella T3 Fleet. And then we have our FA4 line, which you'll notice has the moniker of Ultra attached to it. So we will have a Rotella T5 Ultra 10W30, which is a FA4 product. And we should see so that will be the main that will be the main product that comes out. There are some other things we're working on behind the scenes, but we'll wait till we launch any of those new names.
All right, great. Thank you, Jason. So this was a question with a customer that's currently using a 15W40, and they're wondering what kind of fuel economy improvement they could see if they switch to a 10W30.
So that question is probably mostly focused on if you were today using a 15W40 CJ4, that would probably be most comparable to using a 15W40 CK4, okay? And if you move to a 10W30 CK4, our expectation is that you would see up to 1.6% fuel economy savings. We're working on getting some other numbers on the FA4, but they're not ready for release today.
Okay, great. So this is a good question and one we get pretty often. So we're currently comparing our oils against ourselves. We're comparing our current Rotella formulations to our legacy formulations, and the question is, will we be testing against our competitor oils as well?
And the answer is yes. That is on the books. We're testing our stuff because we have it available. The competitors' CK4 and FA4 products have not been released yet. When they are available in quantity, yes, we will be testing our competitors' products alongside ours.
Great, thank you. So let's see. We've got several more questions came in here. So are the new Rotella T, CK4, and FA4 products using GTL technology?
Okay, so as you'll see with the launch of several of our new products, they're going to be coming with a little bit of a small name change. But in general, yes, many of our new all of our new semi-synthetic and all of the full synthetic grades will be using our gas-to-liquids technology. That is our core Group 3 base oil, and we will be utilizing its properties in our heavy-duty products going forward.
And just to add on to that a little bit, you will notice with our ROTELLA T5 and our ROTELLA T6 products, the Triple Protection Plus inclusion with the icon on the bottles, as well as all of the marketing materials and technical data sheets. And that Triple Protection Plus means that it has the Shell Pure Plus technology, the GTL technology included. All right. Okay, let's see. What are the major differences between CK4 and FA4 oils?
At the outset of that, it's really about its viscosity. So currently, both CK4 and FA4 oils, in order to meet the API specification, you have to run the exact same set of engine test and bench tests. And in fact, you have to pass the exact same level of specification, the exact same level of tests in terms of data points. So there isn't an actual difference in terms of running your program. However, there is a difference in the viscosity. So currently, to be a CK4 engine oil, I'll go back to that term I was using earlier of high temperature, high shear. So you have to have a high temperature, high shear viscosity of 3.5 or greater. But to be an FA4 engine oil, you have to be in a small band, which is between 2.9 and 3.2 high temperature, high shear viscosity. Now, if you write those two down, you'll notice there's a space between the two grades. So 3.5 being anything CK4 and up, but 2.9 to 3.2 being anything FA4. And the reason why there's a space there is to ensure that there is a key core difference, a differentiable difference between FA4 and CK4. So what no customer should see in the market, you should not see an engine oil that claims to be both FA4 and CK4, because according to high temperature, high shear, they can't make that.
Great. Thank you, Jason. And just to note there, if you have any more questions about the differences between CK4 and FA4 oils, and we've done a couple of webinars in the past, and we have some information on the rotella.com website. And we'll be doing a couple of more webinars this year where we will address a little bit more detail around specifically FA4 coming in December. All right, so this question at the top is around stickers on vehicles for the recommended oil, and if we are going to be having any in the future. And so I'll ask that question of Howard.
I've overhauled numerous trucks during our inspection cycle with Chevron Delo stickers on the frame rail. What that sticker indicates is that engine was factory filled with a Chevron product. It says nothing about voiding your warranty if you choose to put a superior oil, i.e. ROTELLA T, in the crankcase versus a Chevron product. And if you will go find a Navistar truck and raise the hood on that one, you will find a Shell ROTELLA sticker on the frame rail of that vehicle. All that indicates is that what that vehicle was factory filled with.
If I add just a piece there, as long as you're using the oil that's specified in the owner's operating manual, in that OEM's operating manual, you should be fine with your warranty. It doesn't say it has to be Chevron or any other marketer there is to date. You simply have to be following what is specified in that manufacturer's documentation.
Great. Thank you both. Okay, let's see. A few more questions here. So one is around backwards compatibility with CK4 and FA4 oils. If you could address both backwards compatibility, Jason, and then also talking about changing from a CJ4 to a CK4 oil there.
So I'll take the first one, which I think is probably the easiest. So today, if you're running a CJ4 engine oil, you can expect that means you're going to have a no-issue transition to a CK4 engine oil. Okay, those specifications are meant to be completely backwards compatible, and those are the expectations of not only ourselves but also the OEMs, so the engine manufacturers as well. The difference becomes where we talk about FA4. So FA4, for some of our OEMs, they are seeing as a 2016 or 2017 and beyond engine oil. And they haven't all certified that an FA4 engine oil is fully backward compatible. Now, we have been doing a fair amount of tests with the FA4 type engine oils, trying to validate the performance of those engine oils in older engines, so pre-2017. And I think, as I've said, as we would say many times, we're happy to work with any customers to try to validate that performance in their service and in their engines. However, we always say you have to follow what's in the owner's operating manual, what was specified by the manufacturer. So in order to not void the warranty, we always recommend that you follow that documentation first.
Great. Thank you, Jason. I'm pretty sure we already answered this question, but I'm just going to clarify. One individual asked about FA4 product, if that will contain Pure Plus technology, and the answer is yes, that it will, as our new FA4 product is a Rotella T5 Ultra. And as we said earlier, our whole portfolio of Rotella T5 and Rotella T6 products include GTL or Shell Pure Plus technology. Okay, there was a question about our testing, and are we testing in extreme temperatures, hot and cold?
The northern tier of Canada for the cold weather, and anything along Interstate 10. I've got trucks running in both routes. The high humidity and the extreme temperatures in the summer are brutal conditions to run in across Interstate 10, and the reverse is possible up in the northern tier of Canada.
All right. Yeah, there's a couple of questions in here about price, and we're not able to go into any discussions about price on this call here, but we would ask that you just discuss that with either your Shell sales representative, your local distributor, or a retailer near you that sells Rotella. We've had a question about testing oil field hauling trucks and the diverse range of terrain there, if we have done any testing.
I tested with a Texas-based oil field equipment, and that's exactly what they were doing. Is they were on road, they were off road, a little bit of everything, until the price of a barrel of oil collapsed, and basically all the exploration work went away. But it's a cost-driven business. If those guys aren't running their trucks, then it just basically just killed off my field trial. That was a site that we had on test for 8.5, 9 years.
One of the things I can add, though, in our development of the CK4 and FA4 oils, we have done off-highway testing. So we've looked at some off-highway mining equipment, some off-highway construction equipment, as well as agri-equipment, trying to, again, extend our ability to validate the performance of our engine oil portfolio. So that's included both the CK4 type lubricants, but also the FA4 type lubricants in some cases. So I can't necessarily say that we may have had that exact a trial in that exact condition, but we definitely have tested in some pretty diverse driving conditions and terrains that we believe has put a severe stress on the oil, but we've seen excellent or stellar performance in all cases.
Okay, so one more question I see coming in here. Do we factory fill any trucks? What trucks do we factory fill with?
We factory fill every Navistar truck that runs off their line with engine oil and extended life coolants.
Great. Let's see. Got another one coming in here, but if you haven't already, go ahead and type your questions in. We got another few minutes, and we can probably take a couple more questions. So this is one that I've heard a lot, and it is, can I switch from a mineral oil to a synthetic or a semi-synthetic, and then could I switch back after that?
Well, if we're doing our job right, you can definitely switch from the mineral to the synthetic or semi-synthetic, and you'll never want to switch back. So the answer to the question is yes, you can switch from mineral to semi-synthetic or full synthetic. You can switch from semi-synthetic to full synthetic. There's no issue there. And yes, there is no issue going backwards as well. But the benefits you will lose, the ones that you gain by going to a semi-synthetic or the ones that you gain by going to a full synthetic, you lose as you go back to a conventional mineral grade. Those benefits tend to be related somewhat to viscosity, but also to oxidation protection, so cleanliness, deposits, and in some cases even wear performance. So there are some key performance indicators and some key benefits that you get by moving from a conventional to a semi-synthetic, and then even more improvements that you can get by going to a full synthetic. So we absolutely suggest you make that transition because it will pay off for you in the long run.
All right. Thank you very much, Jason. All right, so I think that's about it for questions. I just wanted to make sure everybody on the line here knows that we do have 2 more webinars coming up this year, and so really encourage you to do your best to attend those. You'll receive invitations for those coming up on October 13th and then on December 12th. In October, we'll be talking about our Shell Pure Plus technology and how that is included in our products with Triple Protection Plus, like we had mentioned earlier today. So we'll go into a little bit more depth about that. And then in December, we'll talk about the FA4 technology, about our product, and about what you need to know for your business in terms of including that oil in your inventory and filling your vehicles or remaining with CK4. I know there's a lot of questions and concern that people have about that, so we'll go into a lot of detail around it. And with that, I'll turn it back over to Mike.
Great, thank you. Well, I'm sorry to say our time is up, but I want to thank our attendees for taking the time to participate and listen in on today's webinar, the Shell ROTELLA Approach to Field Trials. Also, a big thanks goes out to Jason and Howard for taking the time and putting in the effort to impart valuable information on the next generation of heavy-duty engine oils over the course of the last hour or so. As you can see, in terms of, for going for future information, you will receive an email with a link to the recorded webinar that you saw today. It will be posted on the Rotella and Fleet Maintenance websites. And for our audience, vehicleservicepros.com is the official website of Fleet Maintenance, so go there for more information. If you want to know more about what was covered in today's webinar, as well as Shell ROTELLA and other Shell lubricants, please contact Shell via the link you will receive in the email after today's webinar or at www.lubeeducation.com. That's LUBE-education.com. Also be sure to connect with Shell on social media, whether that's Facebook, Twitter, YouTube, or Instagram. And I just wanted to reiterate that this webinar will be archived on Fleet Maintenance's website as well. So go to vehicleservicepros.com for that. So with that, we will conclude today's proceedings and have a productive remainder of your day.